Welcome to the Crazy Hat Chemist. So we're doing another video in bonding and molecular structure today. Awesome. Let's get moving. Bam! Today we're talking about Lewis dot structure rules. Okay, so we're gonna first, number one, we're gonna total up the valence electrons. Okay, that's the group numbers on the periodic table. And you see that bond blender on the side right there? I got my own bond blender right here. Just a little advertisement. Bond blender. What you got to do here is you got to add up all the bonds that are inside there and then spread them out as you see appropriate to these rules. And that's what your bond blender is all about. Okay, so rule number two. Okay, or part of rule number one, rather. You're going to add for negative charge and you're going to subtract for positive charge. We'll discuss this. Okay, number two, we're going to determine the central atom. The central atom or the central element is always the least electronegative element. That's why we went over the electronegativity values first. Fluorine is the most electronegative. So we're looking for the element that is furthest from fluorine. However, hydrogen can never be the central element. And the reason for that is that hydrogen cannot branch off to other elements, so it's never hydrogen. So it's the least electronegative, but never hydrogen, so it can't be the hydrogen as the central element. Okay, we're going to set up a basic plus or X marks the spot-like structure, and that central element is going to go right in the middle of that plus sign. Okay, number three, we're going to place a pair of electrons between the central atom and the central element and the outside atoms. That forms a single or a sigma bond. Okay, that's when we're starting to dump out the electrons from our bond blender after we hit the frappe button. Number four is we're going to place a pair of electrons on the outside atoms as lone pairs or non-bonding pairs of electrons. Okay, number five, we're going to place a pair of electrons on the central atom as lone pairs or non-bonding pairs of electrons. Number six, we're going to verify the octet rule. Octet is for 8, like an octopus, and the duet rule. There's only one element that follows the duet rule, and that is hydrogen. Okay, we're going to check for exceptions to the octet rule, and that is period 3 and above can exceed the octet rule. Boron and beryllium can be deficient in an octet, and everything else in period 2 must maintain an octet. Okay, number 7, we're going to maintain an octet, we might need to use multiple bonds, and that's double and triple bonds, of which have pi bonds in them, unlike the sigma bonds. We'll discuss the sigma and the pi and what's different or between those or similar. Okay, there's our bond blender. We're adding electrons to this bond blender and then spreading them out according to this set of rules. So you need to either memorize these rules or you just need to have this slide out all the time and use these set of rules repeatedly until you memorize how to do them in the order of which you are following here. It's 1 through 7. Don't forget about the order. That's extremely essential. Okay, the atom and the molecule is all about Mr. Gilbert and Lewis, and he wrote a paper, and this is how we come about these Lewis dot structures. Okay, he wrote this paper, and in this paper in the American Chemical Society in 1916, he published his results, and from those results, we have Lewis dot structures now today. Okay, all right, that's super cool. Look that history stuff up. Okay, I am the Crazy Hat Chemist, and I got a super cool hat for you. Quack, 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 quack. Go Oregon Ducks, baby! Yeah! Give me a thumbs up if you like that video. Subscribe to my YouTube channel. Pass on my YouTube channel to all your favorite chemistry friends. You know someone who needs to learn how to do chemistry. Pass it on to them. Bye now.